Hello and welcome to Mr. Tompkins EdTech. This series of videos and their accompanying predicted papers are my best guess as to what you might expect in your next maths exam. This particular video covers Edexcel Paper 2. I've taken a look at what's already come up along with some statistical analysis of previous papers and drawn up a list of high frequency topics that have not yet been tested and are highly likely to appear in the coming paper. I've then selected some typical questions that you might expect to see on each of these topics and created a diagnostic paper for you to try. You'll find the link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on, and more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description, you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations, and let's get into it. Write the number 6,005,200 in standard form. Okay, let's try and write it out as a number first off. So 6 million is 6 followed by 6 zeros. Or 6,005,000, so that's going to be 005 200, like that. 6,005,200. Okay, now we've got it written as a number. Now we can try and write it in standard form. So we're just going to write all the digits. 6.0052. I can forget about the last two, so I'm not going to change it either way. So times what? 10 to the power of, well, if the decimal point starts here and we're going to end up 1, 2, 3, 4, 5, 6, we're going to move it 6 jumps to get it to there, aren't we? So that's times 10 to the power of 6. So my answer is 6.0052 times 10 to the 6. Question 3, write the following numbers in order of size. Start with the smallest number. Okay, and I've got 1.02, 0.12, 1.20 and 0.21. Okay, now you need to compare like with like. So if we're looking at the first digit of each number, the first unit number, isn't it? The ones column. You can see some of them are ones and some of them are zeros, and obviously the smallest ones are going to be the ones that start with 0. So it's going to be out of these two here then, isn't it? Which one is the smallest out of these? So I know it's going to be one of these two. Let's have a look at the next digit along. Next digit along, I've got a 1 and a 2. So we're going to pick the one with the smallest digit, and that is 0.12. So 0.12 is the smallest, and then 0.21 is the next biggest. Okay? Let's look at the second digit of our numbers that start with 1. I've got 0 and I've got 2. So again, picking the one that's got the smallest digit first. 1.02 is next and 1.20 is last. Okay, so 0.12, 0.21, 1.02 and 1.20. Question 14a. Use your calculator to work out 9.95 squared times 29.8. Okay, so we've managed to gain quite a few marks already in this paper just by being able to type nicely into my calculator. So 9.95 squared times 29.8 equals, write down your full calculator display. So 2950 2950.2745. Okay, that's what I got. Right, question 14b. Is your answer to part A sensible? Use approximations to decide. You must show your working. Okay. So what asking me to approximate that answer now and compare it with my answer to make sure that I did it correctly. Okay, so let's do that then. So if I look at 9.95, I'm going to round each one of these numbers off to one significant figure. So the first significant figure in 9.95 is the 9, which is in the units column. So 9.95 to the nearest unit rounds up to 10. So I'm going to get 10 squared times 29.8. So the first significant figure of this number is the 2, which is in the tens column. So let's round 29.8 off to the nearest 10, which is 29.8 is nearest to 30, isn't it? It's nearer 30 than 20. So it's going to be 10 squared times 30. Okay, so let's work out down here 10 squared times 30. Well, that's just 100 times, not 106, 100 times 30, which is 30 with 2 extra zeros, 3,000. Okay, so my estimate was 3,000. My actual answer was 2,950. So that's not bad, is it? It's only 50 out, which is not too much when you're talking about thousands. So yeah, I'm going to say it was sensible. Question 12. Reflect shape A in the x-axis. Now the x-axis is this axis here. So that's going to be the mirror line then, isn't it, that we're going to do the reflection in. Now, don't try and reflect the shape. Reflect the vertices of the shape, the corners, and then draw your lines between the corners that you have found where they lie. Now, for each corner, you just need to find how far away it is from the mirror line, and then plot it the same distance on the other side of the line. So that corner there is 1 unit away, so it's going to end up there. That one is 1 unit away, and that top corner there is 1, 2, 3, 4 units from the mirror line. So its image is going to be 1, 2, 3, 4 units from the mirror line. It's going to be down there. Okay, once you've finished drawing your points, then you can join them up with a nice straight line. Like that isn't. Let's try that again. Come on, auto shape, do your biz. Okay, that's it. Okay, so that's my image there. Question 4. Circle the unit of mass. Millimeters, that's a length. Grams, that is a mass, isn't it? Liters is a volume. And degrees is an angle. So it's going to be grams. Question 5. Write down all the whole numbers between 91 and 120 that have exactly 2 digits the same. Okay. So 2 digits the same. Well, 91 to 99 are 2-digit numbers, so both have to be exactly the same. And the only one there is 99. Once we get to 100, we move to 3 digits. So exactly 2 the same. Well, we could have 101, couldn't we? And then the next one we're going to get is 110. That's got 2 1s in it. No, next one 111 has got 3 1s, so that isn't exactly 2. But we can have 112, and in fact all the other ones that follow, can't we? 115, 116, 117, 118. And 119. Are there any more? So we get to 120 and then all those are different. I think that's all of them. Question 8a. Simplify 3a plus 7b minus a plus 4b. Okay, so we need to collect like terms. So we've got terms in a, 3a minus a, and we've got terms in b, plus 7b and plus 4b. Now notice when I highlight those I highlight the sign that goes in front of them because that is part of what we're doing, isn't it? So 3a subtract a is 2a, and 7b plus 4b is 11b. So we get 2a plus 11b. 8b, expand 4 lots of 2d plus 5. So single brackets, a number on the outside, that gets multiplied by everything inside the bracket. So 4 times 2d is 8d, and 4 times 5 is 20. There's a plus sign in the middle, so it must be plus 8d plus 20. Finally, we're asked to factorize 15x plus 18y. Now that's pretty much the opposite of what we were just doing. Expanding removes brackets and factorizing puts them back in. The thing that goes on the outside of the bracket is the thing that's common to both terms. So we've got an x in one and a y in the other, so they're not common, but we've got a 15 and an 18. 15 and 18 are both in the 3 times table, so I can put a 3 on the outside. Now, to work out what goes on the inside of the bracket, we just need to think about, well, what 3 times what is going to give me 15x? Well, 3 times 5x gives me 15x. I'm going to have a plus in between. And 3 times what gives me 18y? Well, 3 times 6y must give me 18y. So I get 3 lots of 5x plus 6y. Question 9. Jack and Liam each get the same pocket money. Jack spends 75% of his and has £2 left. Liam spends 40% of his. How much does Liam have left? Well, if Jack spends 75% of his and he gets and he's got £2 left, then 25% is what he has left, isn't it? And that is equal to £2. So if 25% is equal to £2, then 100% is going to be 4 lots of that, then, isn't it? Okay, and 4 lots of £2 is £8. So that means that Jack must have had £8 pocket money to start with. Now we know that Liam has the same amount of pocket money, so he must also have £8. So if he spends 40%, then he's got 60% of his pocket money left. So what we need to do is to find what 60% of 8 is. So using our triangle, final, original, multiplier. Our final is what we're trying to find. Our original is £8, and our multiplier, let's say we want to find 60%, don't we? 60% of the amount, which has a multiplier is 0.6. So to find our final, just cover that up, is original times multiplier. Final is equal to original times multiplier. So 8 times 0.6, which is, according to my calculator, 8 times 0.6 is 4.8. Now remember, this is money though, so we're going to have to write that as pounds and pence. So he's got £4.80 left. Now you could have also found out what 40% was and deduct it from the £8 to get the same answer if you wanted to, but this way is quicker if you know what you're doing. Question 8. Here is a map of a town, and you can see on the diagram here we've got various things marked on it. We've also been given up here a scale. 1 centimetre represents 200 meters, so we can work out how far things are from each other. And we've also been given a direction up here, so this way is north. Okay, so I'm sure that's going to come in useful for the question. What is the question? Which place is exactly northwest of the station? Circle your answer. Okay, so compass points. They've given us north there. You should know that opposite north is south, and then you've got west and east like that. And then between north and east you have northeast. Between south and east you have southeast. Between south and west you've got southwest. And between north and west we've got northwest. So we want to know what's northwest of the station. So northwest is in that direction, isn't it? So if we start at the station and we go northwest, let's just get my ruler out to demonstrate that. So northwest is that direction, isn't it? So starting at the station and going northwest you can see that the line goes straight to the library. So the answer is the library. Okay, so let's ring that one. Next it says, circle the 3-figure bearing of the monument from the park. Okay, so 3-figure bearings are the angle measured clockwise from north. North is considered to be 0, 0, 0, and then if you measure around to the direction you want to go in, then you can find your bearing. So the 3-figure bearing of the monument from the park. So going to the monument from the park, well, you can see you're going directly to the monument from the park is going directly downwards, isn't it? So let's just mark that one. It's going that direction. Okay, so we said this way is north, so I'm going an angle of 180 degrees around from the north line. So that is going to have a bearing of 180. That one. Any more? Yes. 8C says, what is the distance in meters from the cinema to the station? So cinema to station. Again, I'm just going to join those up with a ruler so I can see them. Now this is a bit of a slant line. So we could measure it, I suppose, because we've got the scale in centimeters. So we can measure it with the ruler and then and multiply it by the number of centimeters by 200 meters, and we'll find the distance. Now my ruler here is a kind of electronic one. It's not going to calibrate nicely with that page, but if you've got a proper ruler on a proper exam paper, you can just measure it to the nearest millimeter. And having done that properly, I made it 5.8 centimeters when I measured it on the real paper with a real ruler. So if it's 5.8 centimeters and I know that 1 centimeter represents 200 meters, if I times 200 by 5.8, I should get the distance. So 200 times 5.8, what's that equal to? Let's reach for the calculator. 200 times 5.8, that gives me 1,160. 1,160 meters, so that's my answer. There's probably a little bit of leeway either side. Probably you're allowed anything from about 1120 up to 1200, I'd imagine, but I made it 5.8, which is 1160. Finally, 8D says, why might the shortest walking distance from the cinema to the station be greater than your answer to part C? Okay, so why might the shortest walking distance from the cinema to the station be greater than your answer? Well, if you come back to the diagram here, you can see that this path is direct, and there might be things in the way. This monument there might be a fence around this monument that you have to then go around. So the actual walking distance might be longer than the direct route, because there might not be a path all the way through. So I'm going to write something like that down. So why might the shortest walking distance be greater than your answer? There may be obstacles in the direct path so pedestrians would need to walk around these. Something like that. So there may be obstacles in the direct path, so pedestrians would need to walk around these. Question 9. Complete the bank statement. Now I don't know if you've got your own bank account, but if you do, you'll know that credits are amounts paid into your bank account and debits are money going out again, although probably you don't have a lot of experience yet of paying things like council tax. Lucky you. But anyway, so let's assume that you started with a starting balance of £212.48, like we've demonstrated here, A debit of £128.39 is that money coming out of your account. So if I type in 212.48 into the calculator and subtract the £128.39, which is going out, that leaves me with £84.09. £84.09. Okay, next day, this person's salary is paid in, so they're getting paid £856.21. That's a credit, which is money coming into the account, so I need to add that on. So adding on £856.21 gives me a new total of 940.3. 940.3. Now remember, with pounds and pence, we always write those to 2 decimal places because it is pounds and pence. Okay, so the answer is 940.30 and not 940.3. You will get marked down in these sorts of questions if you don't put that extra 0 on. Question 10. The average age of teachers at a school is 36 years. Mr. Smith's age is 11/9 of the average. How old is Mr. Smith? So what we're being asked to find here is 11/9 of 36. So when we've got a fraction like that, well, if you've got a nice calculator like this, you can just type in the fraction, 11/9. Otherwise, you can just multiply by 11 and divide by 9. But I make that 44. So Mr. Smith is older than average. Question 11. Solve 4x minus 3 is equal to 14. 4x minus 3 is equal to 14. Now, the confusion with this is often about which one to move. People will know they have to kind of either add 3 to both sides or divide both sides by 4, but they sometimes get it in the wrong order. You need to attack these in the opposite order of BIDMAS. Okay, so if you knew what x was, let's say you knew x was 2, you'd evaluate it by multiplying it by 4 and then subtracting 3. So when you are unwinding these equations, you need to work back the other way. So going backwards through the list of BIDMAS, I'm going to move this subtraction first. Subtraction I'm going to move before I get to the division and multiplication. So I either change sides, or subtracting 3 from both sides. You're going to get 4x equals 14 plus 3. So 4x is equal to 17. And then either cross multiplying the 4 to the other side or dividing both sides by 4. You're going to get x is equal to 17 over 4. Now, whilst it might not feel like it to most GCSE students, 17 over 4 is actually a very acceptable answer. It's just a top-heavy fraction. If you did want to rewrite it as a mixed number, you can say, well, how many times does 4 go into 17? 4 goes into 17 4 times, and the remainder is 1. So 17 over 4 is 4 1/4. So you could rewrite it like that, or 4.25. You could even type it into your calculator if you wanted to, but 17 over 4 is actually a perfectly good answer. Question 8. A game is played with a fair spinner. You can see on the spinner it's got the numbers 1, 2, 3 and 4. They're all equally as likely because they're all exactly the same size as each other. The player spins the spinner twice. The score is the difference between the two numbers. Now, difference means in mathematics subtract. So you're going to subtract one score from the other. So complete the table to show the scores. So if I got 1 in the first spin and 1 in the second spin, then 1 subtract 1 is 0. If I got 2 in the first spin and 1 in the second spin, then 2 subtract 1 is 1. 3 subtract 1 is 2, and 4 subtract 1 is 3. If I got 1 in the first spin and 2 in the second spin, then 2 subtract 1 is also 1. 2 subtract 2 is 0. 3 subtract 2 is 1, and 4 subtract 2 is 2. And I can just fill out the rest of the table in the same way. So 3 subtract 2 is 1, 3 subtract 3 is 0, 4 subtract 3 is 1, 4 subtract 1 is 3, 4 subtract 2 is 2, 4 subtract 3 is 1, and 4 subtract 4 is 0. So let's have a quick look then at the next question. It says, the player loses if the score is 0 or 1, and the player wins if the score is 2 or 3. Now Amy says 2 scores win and 2 scores lose, so the probability of winning is evens. Is Amy correct? Tick a box. Okay, so she's correct in that there are 2 outcomes that are a win and 2 outcomes that are a loss, but that's not necessarily equal chances of getting those 2 things. Let's have a quick think about this. What's the probability of getting a 0 or a 1 in this game? Well, probability is equal to successful outcomes divided by total outcomes. Now there are a total of 16 outcomes here. I've got 4 rows of 4. And how many of those outcomes are 0 or 1? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's actually 10 outcomes that are 0 or 1, giving you a probability of success of 10 out of 16. Whereas the probability of getting a 2 or a 3, how many of those are there? I've got 1, 2, 3, 4, 5. I've only got 6 of those. So the probability of getting a 2 or 3 is 6 out of 16. So she's far more likely to get 0 or 1 and therefore lose than she is getting a 2 or 3, which gives you a win. So is Amy correct that it's evens? No, she's not correct. Give the reason. There is a greater probability of obtaining a 0 or 1 than 2 or 3. Question 11. The diagram shows a sequence of patterns, and you can see here that we've got 3, 5, 7 and 9 circles in those patterns. Work out the number of circles in pattern 6. Well, each one we're adding 2, aren't we? This is a +2 sequence. So if I'm going from pattern 4 to pattern 6, I'm going to be adding 2 and adding 2. So for my 9 plus 2 plus 2, it's going to take me up to 13, isn't it? It's going to be 13. Complete the rule below. Number of circles equals the pattern number times a number plus a number. Okay, basically they're asking us for the nth term of this sequence, aren't they? So this sequence is going up in 2s, so it has something to do with 2n. I'll have to multiply it by 2. And if you look at the first pattern, we've got 3 in the first pattern. So if I took the first pattern and multiplied it by 2, I'd have to add on 1 to get up to 3. So it's the pattern number times 2 add 1. Which pattern has 51 circles? Okay, so if the nth term is 2n plus 1, like we just talked about, and that is equal to 51, we can kind of solve that like a linear equation. Subtracting 1 from both sides is going to give me 2n is equal to 50, and then dividing both sides by 2 tells me that n is equal to 25, so it's the 25th pattern that has 51 circles. Question 12. A minus b is equal to 5. Part A says work out the value of 2 lots of a minus b. Now note that we don't know what a and b are, but we do know that a subtract b is 5. It's given here. So if a minus b is equal to 5, I can replace this a minus b in here with the value of a minus b, which is 5. So in other words, I've got 2 lots of 5 here, and 2 lots of 5 is just 2 times 5, which is 10. Okay, so work out the value of 2 lots of a minus b. The answer is 10. Okay, now part B says work out the value of 7a minus 7b. Now can we do something similar here? Now you notice I've got a 7 and a 7 in both terms, so they're common, aren't they? So I can factorize out that 7 and rewrite this expression as 7 lots of a minus b. Now again, I've got this expression at the end here, which is a minus b, and I know that that is worth 5. So then I can do the same thing. I can replace it with the value 5, and 7 5s are 35. So 7a minus 7b must be equal to 35. And then finally it says work out the value of b minus a. Okay. How can I work out the value of b minus a? A minus b is equal to 5. What is the value of b minus a? Now there's a quick and easy way of doing this. It's moving everything around on the equation. So if I take this minus b and take it to the other side, it becomes plus b. If I take this 5 and move it over here, it's going to become minus 5. And if I take this a and I move it over here, it's going to become minus a. So you can see that b minus a, which is what I was trying to find, is equal to negative 5. So the answer is negative 5. Now this is using something, a quick shorthand method of rearranging called change sides, change signs. So it might be something quick and easy that you can remember. So if you take anything from one side of an equation over to the other side of the equation like this, you have to flip its sign as it goes over. So that a became a minus a, the minus b became a b, and the 5 became a minus 5. Question 15. A company uses this formula to work out cost A of a taxi ride. So cost A is equal to 4 plus 1.8 times M plus B. £4 is the fixed charge. £4 is a fixed charge, so that's that bit there of the calculation. M is the number of miles travelled, so the miles travelled here is M, so you times that by 1.8. So basically you're being charged £1.80 per mile plus the fixed amount of £4. And then B is the booking charge online, so then you also have to pay that amount on the end. Okay, doesn't say what the booking fee is at the moment, maybe that tells us later on. 15A says Claire books a taxi online and travels 8 miles. So this is going to be the value for M, isn't it? She pays £20 altogether. How much is the charge for booking online? Okay, so A, this is A, isn't it? We've been given the total altogether. We've been given the number of miles. 4 is a fixed number, B is a fixed number, so we should be able to work out B from here. Let's just sub in what we know. So A equals 4 plus 1.8 times M plus B. Okay, so what do we know? We know A is £20. We know that M is 8. We don't know B. That's what we need to find. Okay, so I've got 20 equals 4 plus 1.8 lots of 8 plus B. What's 1.8 times 8? 1.8 times 8 is 14.4 or £14.40. So that's 20 equals 4 plus £14.40 plus B. Let's just add these bits together first. So 20 equals 4 plus 14 is 18, so that's £18.40, isn't it? Plus B. So now we can subtract £18.40 from both sides. See what we're left with. So 1840 subtract 1840 on the right, they're going to disappear, aren't they? Leave me just with the B on the right hand side. And 20 subtract £18.40 leaves me with £1.60. So that must be my booking fee, £1.60. Okay, now part B says a different company has a fixed charge of £3, charges £1.90 per mile, and has no charge for booking online. Write a formula for the cost C of a taxi ride with this company. Okay, so C then is going to be my fixed charge of £3 plus my £1.90, 1.9 lots of my mileage, which if you remember rightly, is m. So C equals 3 plus 1.9 times m. The diagram shows the position of a tap when off and fully on. The tap is fully on when the angle of turn is 180 degrees. So when it's pointing up, it's off, and when you turn it around to face downwards, it is fully on. So when fully on, water flows out of the tap at 14 litres per minute. The rate at which water flows out is in direct proportion to the angle of turn. So the tap is turned to 135 degrees and water flows into the tank with a capacity of 79.8 litres. Will it take less than 7.5 minutes to fill the tank? You must show your working. Okay, so this is an interesting direct proportion question. We know that the rate of water flow is in direct proportion to the angle of turn. So let's call F the flow, and let's make T be the turn. Okay, so we know then that the flow, F, is in proportion to T, the angle of turn. Okay, so I'm going to say that F little fishy T, which means is proportional to, then I can replace that symbol of proportionality with equals to K lots of T, like that. So F equals KT, where K is the constant we need to find. Now, normally at this point, we're given two values that go together so that we can evaluate K. Now, the pair of values that we know that go together are that when it is fully on, then the flow rate is 14 litres per minute. And fully on, we already know, is that the angle of turn is 180 degrees. So in other words, our turn is 180 and our F is 14. Okay? So we know that when T equals 180, F equals 14. So let's sub those two values in. So 14 then is going to be K lots of 180, and that makes K 14 over 180 then, doesn't it? K equals 14 over 180. Does that cancel down? 14 over 180 cancel down, well, not very much, 7 over 90. Okay, so then the complete equation then, so we're saying this cancels down to 7 over 90. Okay, so the complete equation for this relationship is F is equal to 7 lots of T over 90. Okay, so now we've got a formula that links F and T together. We can find what F is at T at any given T. So we want to know what the flow is here then when the tap is turned to 35 degrees. What is the value of F at that value? Okay, so we're going to write down when F equals 130, well, sorry, when T is equal to 135, what's F? Okay, then F is going to be 7 lots of 135 over 90, which is 7 times 135 divided by 90, 21 over 2. 21 over 2 is what, 10.5? Okay, 10.5 watts. The units is litres per minute, isn't it? So that's 10.5 litres per minute. Okay, running out of space a bit here. So if the flow is 10.5 litres per minute, let's come back up here then. So 10.5 litres per minute. Will it take less than 7.5 minutes to fill the tank? Okay, will it? Well, the capacity of the tank is 79.8 litres and it is filling at 10.5 litres per minute. So if we divide one by the other, we'll find out how long it takes. So time is going to be 79.8 divided by 10.5. So what's that? 79.8 divided by 10.5. That gives me 38 over 5, which is the same thing as 7.6. Takes 7.6 minutes. Will it take less than 7.5 minutes to fill the tank? Well, 0.6 is more than half a minute, isn't it? So my answer is no. It takes longer than 7.5 mins. Okay, that's our answer. Now, it isn't quite in the right place, but you know, the examiner will find it up there. I think that's fine. Let me just underline it there. Maybe put it in the box. Okay, no, it takes longer than 7.5 minutes. I think I've got all my bases covered. This question 5, written as the product of prime factors, 12,600 is 2 cubed times 3 squared times 5 squared times 7. And 14,112 is 2 to the power 5 times 3 squared times 7 squared. Work out the highest common factor of those two numbers. Give your answer as an integer. Well, we can easily work out HCFs of two numbers if we've got them in factor form like this. I'm just going to write them out in expanded prime factor form so we can see all of the individual factors clearly. Okay, so that's 12,600, and then 14,112. That's 2 times 2 times 2 times 2 times 2 times 3 times 3 times 7 times 7. Okay, so the HCF will be made up of all the terms that are in both. Okay, so I've got a 2 in both here, I've got a 2 in both here, I've got another 2 in both here, and I've got more 2's in the bottom number. I haven't got any more to match it in the top one. I've got 2 3's in both, 3's in both, and I've got a 7 in both. Okay, so altogether what I've got in both is 2, 2, 2, 3, 3, 7. Okay, and then if I multiply those all together, that is going to give me my HCF. So 2 times 2 times 2 times 3 times 3 times 7. What's that then? 2 times 2 times 2 times 3 times 3 times 7. That comes out to be 504. Okay, so that's my HCF, 504. Question 6. Beth drives 200 miles in 4 hours. She drives the first 18 miles at an average speed of 36 miles per hour. Work out the average speed of the rest of the journey. So we've got a question here involving distance, speed and time. You can remember how these are related using this triangle. It's the DST triangle. D at the top, S and then T. They're alphabetically listed, aren't they? D, then S and T. And this tells you how those three things are related to each other. Okay, now we're going to look at this journey in 3 different ways. First off, we're going to look at the whole journey, so the total journey. Now the total journey, what is D, what is S, what is T? Well, we've got the distance, which is 200 miles. We don't have the speed, but we have the time, which is 4 hours. But we can find S then using the other two. So we just cross off, kind of stick your finger on top of the one you're trying to find, and in this case S. And then the triangle tells you what to do with the other two. So average speed, oops, let's write in blue. Average speed is distance traveled divided by time taken. In this case, it's going to be 200 divided by 4, which is 50, isn't it? 50 miles per hour. Okay, so that's the average speed for the whole journey. Right, so does that help us? What does the next part says? It says she drives the first 18 miles at an average speed of 36. So I'm going to write this. This is the stage 1 then of the journey. There's 2-stage journey, isn't there? The first section, we know D and we know S, but we don't know T. So let's find T. Let's see if that helps. So we know that the distance is 18. We know that the speed is 36. So what we want to find is time. So again, going back to the DST triangle, if you cover up T, you can see that time is going to be distance divided by speed. Okay, which is going to be 18 divided by 36, which looks like a half to me, 0.5. So what's the units of that then? So this is time in hours then, isn't it? So 0.5 hours, that's half an hour or 30 minutes. Okay, I'm just going to leave it in hours for now. Okay, so then stage 2 of the journey, what do we know about this stage? Do we know anything about it? We know the total distance travelled was 200, and we know that distance travelled in stage 1 was 18. So the distance travelled in stage 2 then is going to be 200 minus 18, and isn't that's going to be 182 miles. Do we know the speed? No, that's what we're trying to find. Do we know the time? Well, again, we know that the time for the whole journey was 4 hours. We've just calculated the time for stage 1 to be half an hour. So that leaves us with 4 subtract half an hour. That leaves us with 3.5 hours then, doesn't it? For the second stage of the journey. Okay, and then we want to find the average speed of this part of the journey. So again, from the triangle, cover up S, tells me that speed equals distance over time, which is now 182 divided by 3.5. Okay, time to reach for a calculator, I think. So 182 divided by 3.5 comes out to be 52. Okay, so that's 52 miles per hour then. Question 8. Doug owes an amount of £600. He wants to pay off this amount in 5 months. He says, each month I will pay back 20% of the amount I still owe. Show working to check if his method is correct. I don't think this is going to work, Doug. If you're just paying back 20% of what you still owe, this is a kind of never-ending sum, isn't it? Basically, it's like compound interest, isn't it? So you've got, for percentages, final, original, multiplier. The final is what we're trying to find here. The original is 600, and the multiplier, so if he's paying back 20%, then he's retaining 80% of the value then, isn't he? So you're basically times him through by 0.8 each time. So after 5 months of paying back 20%, your final then equals original times multiplier, which is 600 times 0.8, but we're doing this 5 times, aren't we? So it's to the power of 5. So after 5 months, how much will be left? 600 times 0.8 to the power of 5. That gives me £196.61. That's remaining to be paid, isn't it? So he has not cleared the £600. Okay, I think I'm just going to sign off like that. So I've shown it, haven't I? Question 9. The diagram shows the scale drawing of a sandpit ABCD. It also shows the arc of all points in the sandpit that are 80 centimetres from the corner A. We're told that the scale of 1 centimetre represents 20 centimetres. A game is played by throwing a ball into the sandpit. Points may be scored when the ball lands in the sandpit. 1 point if the ball lands within the 80 centimetres of corner A, and 1 point if the ball is closer to side AB than to side AD, and 1 point if the ball is closer to corner A than it is to corner B. By completing the construction, find and shade the regions where 2 points can be scored. Show all of your construction lines. Right, now the first construction is already done for us, isn't it? So the the one where it has to be within 80 centimeters from corner A, that circle has already been drawn. It's that arc, isn't it, there? Yeah, so you can see this one is 4 centimeters, which is 80, so that has already been done. So I'm going to move on to the second one, which says 1 point if the ball is closer to side AB than AD. Okay, so the construction that we need for the points that are equidistant from two lines is the angle bisector of those two lines. Okay, so what we're going to have to do is construct the angle bisector. Now normally I would put the compass at A first and do an arc that cuts both, but we've already got this handy arc already drawn, so I'm just going to use those 2 points to mark my cross in the middle to make the angle bisector. Okay, so that makes my job a little bit easier. So sticking on either end, we're drawing a little arc, and then where they cross, that is going to be where my angle bisector is going to go through. Okay, so the line I'm drawing are all the points that are equidistant away from those two lines. So clearly if I want it to be closer to AB, then I want it to be below that line there then. Right, next construction. The point of, if the ball lies closer to A than to B. So the points that are equidistant from two given points A and B are going to be the perpendicular bisector of that line. Okay, so in order to draw a perpendicular bisector, I'm going to set my compass to a little bit over halfway between those 2 points, and I'm going to draw an arc with the compass based at B. Okay, a bit of a semicircle going on there, and then switch over to A, and I'm going to draw another semicircle. We should find that they meet in 2 places. Okay, it's a little bit off screen. Let me just push it up a bit. So drawing a line through where those 2 arcs crossed, that's going to be my perpendicular bisector. So all of those points are equidistant from A and B. Okay, so if we want the points that are closer to A, then I want the points to the left of that line. As I said earlier, if I want the points that are closer to the line AB than the points AD, then I want those below the angle bisector. Okay. Now in this case, I then want the ones outside of the circle then, because if it's inside the circle, it'll be worth 3 points. But I want to highlight the ones that are just worth 2 points. So inside the circle would meet all 3 conditions, and then they'd be worth 3 points. Now, is there any other place which is worth 2 points? This one here is, isn't it? Because that's inside the circle and closer to A than to B, so that's worth 2 points. What other regions have we got? This one up here is only worth one point because it's closer to A than B, but doesn't meet any of the other conditions. And that one down there is worth 1 because it's closer to AB than AD, and the one at the top is worth 0 because it doesn't meet any of the conditions. Right, so they're the 2 regions that I want, and I've shaded both, so that's job done. Let's move on. Question 11. Joe and Kyle share an amount of money in the ratio 7 to n. Joe gets 35% of the money. Work out the value of n. Okay, so we know that Joe to Kyle is in the ratio of 7 to n. Now, Joe gets 35% of the money, so what percentage would be left then for Kyle? Kyle's going to get the rest then, isn't he? So if I've got 100% and I let Joe have 35% of it, then Kyle is going to get 65% of it. Okay? Can you see that is, well, the relationship between these 2 numbers, that's 5 times bigger, isn't it? Okay? So then n, if I multiply n by 5, I'm going to get 65. In other words, n then must be 65 divided by 5. 65 divided by 5 is 13, so n is 13. Question 11. Use trigonometry to work out the size of angle x. Okay, right, so trigonometry is a right angle triangle, so it's about Soccer, isn't it? Is that how you remember it? Now, easiest thing to do is just label up the sides first. Here's my angle down here. So that means, well, that's the longest side, isn't it? So it's the hypotenuse. This 9 joins onto it, so it's the adjacent, and the one that makes the other side the opposite. So I have been given the adjacent and the hypotenuse, and I want x. So the ratio that includes the adjacent and the hypotenuse is that one there. Cosine. So let's write that out fully then. The cosine of an angle is equal to the adjacent divided by the hypotenuse. Okay, that's the full ratio that we need to use. So then let's sub in what we know. Cos, well, it's x in this case, not theta. Adjacent is 9 and the hypotenuse is 10. Okay, so the cos of x is 9/10. So then x is going to be the inverse cosine of 9/10. Okay, so that, reaching for the calculator, shift cos 9 divided by 10 comes out to 25.84, which we're just going to round off to one decimal place, 25.8. Question 11. A shape is made by joining a right angle triangle to a rectangle. Okay. And then we need to work out the area of the shape. Okay, so we've got two different shapes. We've got area 1, which is a triangle, and we've got area 2, which is a rectangle. Okay, so let's work out area 1 first. Area 1 is a triangle, so triangles normally have an area of half base times height. Now, base doesn't have to be the one on the bottom. Just your base and height need to be at right angles to each other. So I can use this side here as the base, and I can use this side here as the height because they are at right angles to each other, and so that would be perfectly acceptable for finding the area. So then that is going to be a half times 30 times 16, just subbing those values into my equation, and then half of 16 is 8, and 8 times 30, 3 8s are 24, and a 0, that's 240, isn't it? So that's going to have an area of 240 centimeters squared. What about A2? Now A2 is slightly more problematic because, well, it's a rectangle, it's got an easy formula for finding it, but we only know one of them so far, don't we? We know this length here is 52. Okay, so one of them is going to be 52, but what is the other one? We don't actually currently know this one, do we? Okay, we haven't got that one, but you can see that that side there, which is going to be the width of this rectangle, is the hypotenuse of that right angle triangle, isn't it? So I can just use Pythagoras Theorem to find this one. Okay, so here I can use c squared equals a squared plus b squared, where a is 30 and b is 16. Okay, so what's that then? 30 squared plus 16 squared comes out to be 1156. Okay, so then c is going to be the root of that then, isn't it? Root answer, that's 34. Okay, so that means my hypotenuse is 34, so that's 34, so that's 34. Okay, so subbing that into my calculation here, 52 times 34, times that by 30, 52, going to get 1768. And so then the area is going to be those two things added together then, isn't it? So it's going to be 240 plus 1768. That comes out to be 2008 units, centimeters squared. Question 13. The amount spent on clothes by 40 boys and 40 girls in 1 month was recorded. The table shows information about the amount spent by the boys. Okay, and I can already tell from the table, this is a group frequency table. So again, group frequency, they've got the midpoint marked, so I'm guessing they're going to ask me to find that estimated mean. The mean for the girls was £35. Estimate the mean for the girls as a percentage of the mean for the boys. Okay, so obviously the first thing I need to do is find what the mean for the boys is. So as I said, the table is already set up for it. To find the mean from a group frequency table, or estimate the mean, the first thing you've got to do is work out the midpoints of each of the groups or classes. That's because you don't know, out of these, for instance, these 22 boys here, you know that they scored between 0 and 20, but you don't know the precise value, do you, of what they've got now, because the data's been grouped. So we use 10 halfway between them. 0 plus 20 divided by 2 is 10, as an estimate of what those 22 boys spent. Okay, so going down the list and working out the other endpoints, the midpoints. So 20 plus 40 is 60, divided by 2 is 30. 40 plus 60 is 100, divided by 2 is 50. And 60 plus 80 is 140, divided by 2 is 70. Okay, so they're the midpoints that I'm going to be using. So if I'm saying that 22 boys spent, well, I'm estimating £10 each, then between them, if I multiply those together, 22 times 10 is 220. Okay, I'm going to do that for each of my other values. 30 times 9, was that 270? 50 times 6 is 300, and 70 times 3 is, what's that, 210? Okay, adding that up, you can use your calculator if you like, but often it's easier just to do it in your head. So that's 0, and then 2, 7 and 1 is 0, carry 1, and I've got 2, 4, 7, 8, 9, 10, so that adds up to 1,000. Okay. You might want to double check it on your calculator, but I think that's right. So then the estimated mean then for the boys is going to be sigma fx which is this amount here, isn't it? The sum of the frequencies times their values, which is 1,000. Divided by sigma f, which is this value here, the total sum of the frequencies. So 1,000 divided by 40. So what's that? I think it's 25, but let me just double check. 1,000 divided by 40, 25, yeah. Okay, so the estimated mean for the boys is 25. The mean for the girls was 35. Estimate the mean for the girls as a percentage of the mean for the boys. So if you're expressing one number as a percentage of the other, then the number that you are talking about first is the top number, and the number you're talking about second is the bottom number. So then the percentage, it doesn't look quite right here because it's a big one on the top, is going to be the mean for the girls, which is 35, divided by the mean for the boys, which is 25, and they're going to have to turn that into a percentage. Okay, so what's that then? So 35 divided by 25, that gives me 1.4, and times 100 is 140%. Okay, so the mean of the girls as a percentage of the mean of the boys is 140%. Oops, 140. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.